we will look at a couple of problems that are called initial value problems. They'll look something like this. Let f prime of x equal 2x plus 2. Find f of x such that f of 3 equals 10. So let's kind of go through what that means. So we let f prime of x equal 2x plus 2, which means we're given somebody's derivative. We have f prime, and we want to find f of x, which means the antiderivative. We have the derivative. We want to see where did it come from. But specifically, we want to see where it came from such that f of 3 equals 10. So let's think about why there is some specific one that f of 3 equals 10. So first of all, let's find our antiderivative. So if f prime of x is 2x plus 2, we want to think, what did we differentiate and end up with 2x plus 2? So if we differentiated and ended up with 2x, that would have come from x squared. If we differentiated and ended up with a 2, that would have come with 2x. Now, remember, when you find your antiderivative, there's really a whole family of derivatives. And we put the plus c to indicate that there could have been some constant there. Because think for just a minute, if this had been x squared plus 2x plus 5, well, the derivative is 2x plus 2. If it had been x squared plus 2x plus 75, the derivative is still 2x plus 2. So the idea is that c captures the entire family of antiderivatives. It accounts for the fact that there could have been a constant that was in the original in f of x that would not have shown up in our derivative f prime because the derivative of a constant goes to 0. So this is our general solution, our general form. This tells us about the family of antiderivatives that have a derivative of 2x plus 2. We have one extra thing that is asked here. We want to find the specific f of x where f of 3 equals 10. So that means we want to see if f of 3, which means we plugged in a 3, so 3 squared plus 2 times 3 plus c. Don't plug in for c. Remember, it's f of x, so you're plugging in for x's. But if we plug in that 3, we should get a 10 back. So what we're going to do is solve for c. So this is 9 plus 6 plus c equals 10. So that tells me that c equals, 9 plus 6 is 15. If I move that over, that's a negative 5. So c equals negative 5. So the particular solution that has these initial conditions, that f of 3 equal 10, the particular solution is f of x equals x squared plus 2x. And instead of just plus c, the general idea, we're going to put a minus 5. The particular solution, the particular value of c, that would give us the fact that f of 3 equals 10. All right, let's do another one. Let f prime of x equal 1 over x squared. Now we want to find f of x such that f of 1 equals 0. I'm going to do one quick thing and make this f prime of x equals x to the negative 2, because then it's a little bit easier to find the antiderivative of. Okay, so again, I just start by finding the antiderivative. So I know f prime, so I'm going to call my antiderivative just f of x. And I need to take the antiderivative of x to the negative 2. So remember, we do the kind of opposite power rule. So we take our x, we add 1 now, so we'll get negative 1, and then we divide. And then we add our plus c. Let's write this a little bit better, though. How would we normally write this? We might move that negative to the outside and make this 1 over x, and then plus c. So there we have found our family of antiderivatives. And we say family because we're putting that plus c. There could have been any constant we ever imagined there. So we'll put a c as our placeholder. But we want the specific solution where f of 1 equals 0. So f of 1 would be negative 1 over 1. I'm plugging in right here. Plus c equals 0. So that says negative 1 plus c is 0. So that tells me that c is 1. So the particular solution to this antiderivative is f of x equals negative 1 over x, and I'm going to replace my c with a 1. All right, let's do one more. That should be example 3. Forgot to change it. Now we have a derivative, f prime of x is sine of x, and we want to find the antiderivative, f of x, specifically that f of pi gives us a 4. So I'm going to take my antiderivative. So I want to think, what can I take the derivative of and end up with sine? Well, I know sine and cosine are closely related with their derivatives. So if I wanted to end up with a sine, I had to have started with a cosine. But remember, if you take the derivative of cosine, think about like going backwards to check, take a derivative to check. The derivative of cosine is negative sine. So I really need a negative cosine. And then a quick spot check again. What is the derivative here? Well, derivative of cosine is negative sine, and then that negative will cancel it out and get back to just plain old sine x. Okay, plus a c. All right, well, my initial condition tells me that f of pi would be negative cosine pi plus c would have to equal 4. So let's solve for c. So this is negative. What is the cosine of pi? The cosine of pi is negative 1. Plus c equals 4. So that's 1 plus c equals 4. So c equals 3. So that tells me that my original must have been f of x equals, I'm just going to copy down my f of x, negative cosine x. And instead of plus c, I'm going to put plus 3. Okay. The particular solution that fits this initial condition that f of pi had to equal 4 is negative cosine x plus 3.